All right, lastly, in section 1.5, I want to show you how to confirm algebraically that two given functions are inverses. And there are two things that we're going to have to show in order to accomplish this. And it's going to go back to our skills that we learned in section 1.4. We're going to first of all have to show that f of g of x is equal to x, and that g of f of x is also equal to x. And so let's start off with this first example. We have the functions f of x is equal to 1/4 x minus 2, and g of x is equal to 4x plus 8. So the first thing I want to show is that f of g of x is equal to x. And so f of g of x means I'm going to have f of g of x, which is 4x plus 8. And again, remember that that means I'm going to plug 4x plus 8 into my function for f of x. So this is going to be 1/4 of x minus 2, but instead of x, I'm going to put 4x plus 8. And now I'm just going to show that the steps will simplify down to x. And so 1/4 is going to get distributed into this parentheses. And so 1/4 times 4x is going to give me x. And 1/4 times 8 is going to give me plus 2. And then minus 2 is going to simplify to x. Now, secondly, we want to show that g of f of x is also equal to x. And so this is going to be g of 1/4 x minus 2, which means that I'm going to take 1/4 x minus 2 and plug it in to my function for g of x, which says 4x plus 8. And so instead of x, I'm going to plug in 1/4 x minus 2, and then go ahead and show the algebra that it reduces down to x. So distribute your 4 there, that's going to give you x minus 8, and then plus 8, which will reduce to x. And so since we showed these two things here, that f of g of x is equal to x, and g of f of x is also equal to x, we have verified algebraically that these two functions are inverses. Okay, one more example, maybe slightly more complicated with rational functions here. And so we have these two rational functions. We want to show that they are inverses of each other. And so the first thing I'm going to show is that f of g of x, which in this case is 3x plus 7 divided by x minus 1, I need to show that this is equal to x. And so what this means, again, is that I'm going to take that 3x plus 7 over x minus 1 and plug it into my function for f of x, which says x plus 7 divided by x minus 3. And where I have those parentheses, I'm going to plug in my blue function. So 3x plus 7 over x minus 1 and 3x plus 7 over x minus 1. Okay, now I don't like the fractions within the fractions, and so what I'm going to do is I'm going to multiply by the denominator, which in this case is x minus 1, and that is going to get rid of this complex fraction and make it much easier to deal with. And so here we go. This is what's going to end up happening. I'm going to distribute x minus 1 to this first fraction, which is going to make that denominator cancel, and I'm just going to end up with 3x plus 7. And then I'm going to distribute x minus 1 to my 7. And so that's going to end up giving me 7x minus 7. In the denominator, I'm going to do the exact same thing. So x minus 1 multiplied by that fraction is going to leave me with 3x plus 7. And then x minus 1 multiplied by a negative 3 is going to give me minus 3x and then plus 3. If I collect the like terms in the numerator, I notice here that the plus 7 and the minus 7 are going to cancel. It's going to leave me just with 10x. And in the denominator, my 3x and my negative 3x are going to cancel, and 7 plus 3 is going to be 10. And then the last thing that happens is that my 10's cancel, which leave me with x. Now, I'm halfway done. I want to also show the other direction is true, and so I'm now going to show that g of f of x, and my f of x function was x plus 7 divided by x minus 3. I need to also show that this is equal to x. And so what this means is that I'm going to take this red function and plug it into my blue function. So my blue function says 3 times x plus 7 divided by x minus 1. And so where I have those parentheses, I'm just going to put my f of x function, x plus 7 over x minus 3. Now, just like in the first step, I don't like the fractions within fractions, and so I'm going to multiply here by the denominator, x minus 3 over x minus 3, and distribute. So when I distribute to this fraction, don't forget that that 3 is there, so this is going to be 3 times the x plus 7, and then plus 7 times x minus 3. So I'm just going to kind of go a little slower there. And then in the denominator, x minus 3 times that fraction is going to give me x plus 7, and then minus 1 times x minus 3. Now, if I do the distribution, in the numerator, I'm going to have 3x plus 21 plus 7x minus 21. And in the denominator, I'll have x plus 7, and distributing my negative will give me minus x plus 3. Collect the like terms in the top and in the bottom, and what you're going to end up with is 10x over 10, and that will again reduce to x. And so we have verified that these two functions are indeed inverses.